Hello, my name is Steve Samuel from Design Visionaries, and today it's my privilege to show you a technique that we call the advanced shell technique for automotive components. Here we have a stanchion, two stanchions, a rear stanchion and a forward stanchion for an automobile. They're simplified geometries, and these are die-cast geometries. And in general, the way this is done is you will get industrial design surfaces from a program like Alias or Rhino, or you can do them in NX if you're good enough. And they will be industrial design surfaces that will have to be shelled and have to be turned into a real component. Now, as we do this little demo, we're going to be using something called the vehicle coordinates technique. So as you can see, there's a coordinate system in this file. And this coordinate system represents the coordinate system that we're going to use for this automobile. So I've taken the liberty of drawing this little automobile, drawing this little graphic for you, so you'll understand that what we're doing is we're creating all of our geometry with respect to a coordinate system that everybody on the team agrees with. So if you're going to do some chassis work or if you're going to do some accessory work back here, you know that there's a coordinate system that everything has to match up to. So for example, this stanchion that we're building has a vertex right here. And that vertex can be described in XYZ relative to this coordinate system here. So the X would be about 12 feet, and the Y in this case would be about 3.5 feet, and the Z would be about 2.5 feet, let's say. And therefore, when we build this piece of geometry and we're finished, all we have to do to get it into the assembly and sync it up is to make sure that the central coordinate system syncs up. So it's vehicle coordinates, and these coordinates, I've got X going straight back, I've got Y going straight up, and this ordinate is as if there were a flat piece of roadway, and this 0, 0, 0 ordinate is right on the roadway. So, to proceed, we now can start doing our various techniques on this back stanchion. The advanced shell technique is really great for creating things like die-cast parts and injection molded parts. What we have here to start with is the industrial design surfaces that are sewn together in one fat solid, and now we have to scoop this out and do all the things that make sense to make this a die-cast part. The first thing I'm going to do is simplify the file, so we're working with just the geometry that we want to work with. And the next thing I'm going to do is establish a pull plane direction, a direction that we're going to assume that the two halves of the die-cast mold will be pulled apart from. So this is the y-axis. We're going to use that as our pull plane direction, and we're going to use this technique to shell out this part. Now, if everything was simple, we'd be able to use the shell command, and we'd simply be able to type in a wall thickness, for example 0.1, and we'd shell it out like that. And this would be totally unacceptable to do any kind of die casting, because as you can see, it does a nice job, but all of this geometry would be impossible to take out of the mold. There would be a huge undercut, and so that's one of the reasons why we can't just use the shell technique. Another reason is, in many cases, the shell technique, the geometry is too complex for the shell. So I'm going to just delete that. Let's delete that and bring back the geometry. And so now I'm going to show you the shell technique. So I've established the pull plane direction, that's the Y direction, and just as an overview of the technique, what I'm going to show you is how to create a parametric and associative copy of the outside geometry, and then I'm going to take that piece of geometry and I'm going to hack away at it, and I'm going to offset it and do the kinds of things that would be required to create, in essence, the inside of this component. And when I do that, I'll be able to cut ribs out of it and stiffeners and all these different features, and then I'll easily be able to do one large subtract at the end, and then I'll have a finished piece. So to start with, we need a command called extract geometry. It's in the feature more command, and when I go into feature more, it's under the associative copy group, and we go to extract geometry. In this little feature, it is very important to have the associativity switch on and the fix at current timestamp switch, because the fix at current timestamp switch and the associativity switch indicate that if I, or make sure that if I make any changes to the original geometry, the original surfaces, it's going to be duplicated and redone, and everything's going to go with that. So you'll definitely want to have these two switches on. And I select the geometry, I say OK, and that creates an extracted copy. Now the extracted copy is right on top of the original, and so I'm going to hide the original and bring up the copy. And as you can see, I'll put a color code, light blue, deep sky blue, on the copy. Now, NX has a very, very powerful thing called an expressions editor, and I'm going to type in a variable, thickness 0.1, thickness equals 0.1, and that little variable is going to help me as I go through the process of creating different geometry. When I create ribs, I want them to have a relationship to this wall thickness, and when I do some other operations, there's going to be this THK, this variable that drives everything. That's really a very powerful technique. My very next step is to offset what I can. I'm going to use this command called the offset region, and I'm going to select a number of tangent faces, and I'm going to set those faces equal to my variable THK. As you can see, when I type in THK, I need to do a minus THK. That shrinks the geometry down, and as you can see, what I've done, if I have a little clear transparency of the original outside, what I'm doing here is creating a piece of geometry that represents the inside. So now that I've done that, I'm going to start to hack away at the model that I've created. Oops, let's go Control B. Let's get rid of that outside for a second. And I'm going to start hacking away at this model. Now if I bring back the coordinate system that I made to represent the pull plane direction, you can see that if I view it in this direction, all of this geometry out here is undercut, if you will. Everything that every surface on this piece of geometry has to be tilted relative to the y-axis, because that's going to be the direction of pull. So, and it's got to be tilted in this direction, which is opposite of that surface, and it's opposite of that surface. So now I'm going to use a nice little crafty method to lop off, if you will, the geometry that I know will give me troubles. And in order to do that, I'm going to do an extrude command, and I'm going to use a plane that is orthogonal to the direction of pull. And what I'm going to do is define a little piece of geometry. I'm going to use the project curve command to get that little piece and that little piece there. And what I need to do is establish a cutter, if you will, that I'll use, this can be crude, that I'll use to cut off all the geometry that doesn't fit. So for example, I'm going to use a command called point on curve to get those, to get this cutter aligned perfectly. There we go. And I'm going to make sure I have enough geometry so that it will cut everything that I need to cut. And now when that geometry is extruded, we'll just extrude it like that, and we'll go from 0 out this way. So that's going to be a good cutter. But as we cut, we're going to use the draft command, and let's just assume that 3 degrees will be a good draft angle for these surfaces. So when I subtract this big cutter block from the original geometry, I get a piece of geometry that is far more suitable for the center or for the interior, if you will, of what we're creating. Now, I don't want any sharp corners on this piece of geometry because that's a stress riser, and I'm going to put in an arbitrary blend, if you will. Let's just change that a little bit. We'll go to the edge blend tool, and we'll go to the selection intent manager, and we'll just select the portions that make sense to blend. Say apply that way, and we'll blend off these edges as well. Got to select individual ones that make sense and leave out the ones that don't make sense. So there we go. We're going to blend those edges. And now we have a much better piece of geometry. If I bring back the original again, you can see that if we're assuming the y-axis is the direction of pull, that this piece of geometry will actually be pulled out of the mold, is actually able to be pulled out of the mold, and so is this. This is angled relative to the y-axis. Terrific. Now, we don't want to just take this out. We want to create certain ribs in our internal cutter, if you will. So now, operating on this piece of geometry, we can do that. We can go and we can create a datum plane that is offset from the pull plane for a reason that will become very obvious in just a second. So we're going to create a datum plane. I'm arbitrarily going to give it 0.5 inches. And on that datum plane, I'm going to sketch a pattern of ribs, kind of a honeycomb, that I want to have performed on my cutter. So I'm going to go to the sketch command, and I'm going to select that plane on which to sketch. Okay. Let's do a fit command here. Let's get over here. And what I'm going to do now is just by eye. Of course, if this were a production job, I would take more time and do this. It would take a long time or take a while. It would make a terrible demo. But I'm putting in these rib structures, and in just a minute you'll see how powerful this technique is. So I'm putting in a series of curves that represent the ribs that I want cut out of this die. And I'm going to now extrude them with a taper. So I'll select this, and as you can see, I'm extruding from 0 to some arbitrary number. Here we go. And when I extrude, I can use this command called Two-Sided Offset. And I can use a formula. As you can see, it's THK divided by 2 times 0.6 and minus THK divided by 2 times 0.6. So what we're doing is we're taking the nominal wall thickness of THK, whatever THK might be, and we're multiplying it by 0.6 so that the ribs are thinner than the wall thickness. That's just kind of standard operating procedure. And then we're going to take that section and give it some draft. In this case, I'm going to use 1 degree. And that's what we're going to use to establish our rib structures. So now that I've got that all typed in, I can select a number of these line segments that I just arbitrarily put in. And of course, if I were to do this in a production mode, I would have been more careful about where those went. But there they are. They're all cutters. And I'm going to subtract them all from the main body. So there we have it. This is a cutter, if you will. This will become a cutter. And the fact that I can establish these rib cutouts before I do the main subtraction gives me a lot of power. It makes this technique very, very easy. Now I also want a mounting boss in this piece of geometry, and so the mounting boss can be done with an extrusion as well. So I'm going to hit the X key. X key takes me right to the extrusion ability, and I'm going to select a surface or a plane right there that gives me the direction of pull again, and I'm going to create my circle that represents the mounting boss, and the mounting boss has to come through and be subtracted this way, and it also has to have the draft angle on it, as everything does when you're doing a die casted part. So that's going to be subtracted from my cutter as well. And I'm even going to take one little more moment, and I'm going to put some blending around the mounting boss, like so. And if this were a production job, I might spend a lot of time getting rid of some of these sharp corners and blending things and really working on this. But the long and short of it is, now I've got the cutter that I'm going to use to subtract out everything that I need in this tool to make it an injection molded part, to make it a die cast part. So I'll bring back the original, say OK. I'll go to the subtract command, subtract, and there's my target body, there's my tool, and let's just take away the transparency so you can understand what it looks like. I'm going to use the Control W command to get rid of the sketches and the datum planes, and I'm even going to take a moment and render it for you with the True Shading Editor, or actually I'll use the, yeah, that's good. I'll use the True Shading Editor, and there you have it. There's the finished part, and as you can see, it's injection. It's all set for the die casting. The ribs are there. The mounting boss is there. It's hollowed out in a way that can actually be molded. And finally, the fact that I used that THK variable in the beginning gives me the ability to change all the wall thicknesses and the relations that they have to the fins very quickly. I could just say Control E, and that brings up the expressions editor, and I can use this THK variable, and I could make it 0.075, for example. And as soon as I say apply, everything has to update because everything was created with respect to that thickness. So there you have it. Very quickly I changed the thickness. It's beautiful. Very, very powerful technique that will save you untold hours. Thank you very much. Again, my name is Steve Samuel, and this video can be seen, as well as many others, on our website, nxtutorials.com. Thanks again. Happy modeling.